actually taking out the time on a Sunday afternoon to attend this panel discussion. And I would especially like to thank all our panelists for taking their time out on this busy day and out of their busy schedules to basically bring this panel discussion alive. And so the broad theme that we're going to be talking today is public understanding of mathematics and mathematicians' understanding of society. And the theme was suggested by Arul, which I think was a rather interesting title. And in this, we actually talk about how does math relate to society in multiple different ways. And there's a bit of irony when we talk about maths and society as if they're two distinct entities, because maths is essentially the process of at least doing mathematics, essentially a social process. I mean, this is regardless of what we really think about the nature of mathematical reality and other such questions. And being a social process, society tends to influence it in multiple different distinct ways. And mathematics simultaneously also influences society in very multiple different ways. So for instance, as much as we really wanted to believe that we were living in this ivory tower of abstraction, at least some of us in math, which was completely disconnected from reality, the problem of today finding a hypergraph in an n-dimensional space can be used to determine if a farmer can access a loan or not, right? I mean, through this whole prism of machine learning and then data science. So mathematics today is basically influencing society in multiple different ways. And another way we are increasingly seeing during COVID-19 is, let's say, a pandemic model can start influencing national policies on pandemic and lockdowns. So there, at this kind of juncture, it becomes really understand what does mathematics mean to the public and several questions that it subsequently poses. So what does public have to gain from an understanding of mathematics? How do we really do it? And then the question of what does it really mean to do mathematics in a society, especially society that's highly unequal. And especially when we also look at the mathematical community itself and we looked at various factors in which the representation can be skewed, such as gender. So what does it really mean to do mathematics in such a skewed composition, I mean, with such a skewed population, and how does it really affect the practice of mathematical education and research? And then again, it also questions, can we really make mathematics useful to society? And then also it brings us to the very important question, which is last, but still important, is that mathematics exists in this world of very abstract and precise reality. And then we have this precise language, lovely abstractions. And yet there is a really messy and complex world of society and social processes that shape the society. So can we really use mathematics to kind of explain anything about society? What kind of insights do we obtain about society by using mathematics? So these are really diverse topics on each of its own right, and each of these questions can lead to several PhD theses. But our panelists will try and basically bring some of these aspects to you in a short period of 10 minutes. And I'm really excited by the panelists that we have today here. So we have going to be starting with Anand, who's going to talk about what does it mean, what is the mathematics of social processes and society. Then subsequently, it's going to be followed by Tathagata, who's going to be, Om Damani, who's going to talk about what does it mean to do mathematics for society. Then Tathagata is going to bring to us what does it mean to do mathematics in society, especially in a very unequal society like us. And Nija will finally conclude by talking about what does it mean of what does gender representation mean for the practice of mathematical education and research. And to begin the first talk with Anand, so brief introduction to Anand. Anand is an assistant professor of mathematics and economics at Kriya University, and he's interested in using mathematics and complex systems to understand various phenomena such as inequality, poverty, and segregation. So over to you, Anand.
Thanks, Prathamesh. I'm just going to share my screen to get started. Is it visible?
Yes.
Yes. Thank you. So thanks, Prathamesh. Thanks to the organizers for having me here. It's a pleasure to be here on Sunday evening to talk to you about, mathematics of social processes. About 10 years back, I worked with an organization where one of the things we were trying to do was to work with small cities, right? Cities with populations of 50,000 and below, to see if we could sustainably finance local infrastructure. So specifically, we were thinking about things like, water supply projects, sanitation, garbage disposal, waste management. And we started working with the town of Srirangapatna in Mysore, which is on the Bangalore-Mysore Expressway. And it's a small town of 25,000 people. Now, what we wanted to do with them was to work with the local government and try and identify projects that we could help finance. One of the first things that we found out very quickly was the fact that there was a complete lack of data to understand the city, its current state, etc. So we didn't know what kind of infrastructure was there in the city, where it was located. There were no maps of the underground network infrastructure, the water and sewerage that we could get hold of. Now, people in the city council, of course, individuals had a sense of, what was happening, but there was no systematic way in which data was collected and processed. And therefore, our project very quickly changed into one of trying to understand, how a small city like this actually works in India, right? There is so much happening at the level of a small city. More than 40% of India's urban population lives in cities like Srirangapatna and slightly bigger. So how do these cities actually function? And we spent about 4 or 5 years with them trying to explore some of these questions. And some of the things that we find out were quite, staggering. So for instance, even at that sort of microcosm of 25,000 people, we find that neighborhoods across this city are extremely unequal. We find that some neighborhoods have slums, some don't, and about 20% of the population of Srirangapatna actually live in slums. We found that Hindus and Muslims lived in very segregated uh, residential quarters in the city. Now, this might be true of larger cities in India, but it's also very true in such small, at this level of disaggregation as well. And one of the things that got me very interested in was how some of these outcomes sort of perpetuated themselves over time. So for instance, it was very easy to see that this was a city with 23 wards. Each ward had a councillor, which represented the ward in the city council. And when decisions are made on, what kinds of expenditures need to be undertaken and where they need to be undertaken, a look at their financial records made it clear that the richer neighborhoods got a lion's share of the funding, the expenditure, while the poorer neighborhoods were further impoverished over time. So what we were seeing was, inequality sort of, persisting and sort of exacerbating over time. We saw segregation as a result of this, again, exacerbated over time. And I got very interested in sort of looking at some of these aspects like governance, infrastructure, social relations, and economic structure, and how they interacted with one another to produce these various outcomes on inequality or poverty or segregation that was so apparent to us. And now these questions of poverty, inequality, segregation, they've been studied for over 100 years by economists, sociologists, anthropologists. But my interest was in, taking the tools of mathematics and physics in trying to see if, these interconnections could be explored. There are new insights that we can gain from using some of these tools in the study of social processes. Now, this is not a new or a revolutionary idea. In fact, many scientists have been talking about, using these tools, and in fact, use these tools in non-physical systems. In fact, in 1948, Warren Weaver, in his sort of description of the progress of science, said that science had made a lot of progress in what he called systems of simplicity, which were, two variable systems as sort of exemplified by Newtonian mechanics, and also in systems of what he called disorganized complexity. So, this was what this was the use of, probability theory and statistical mechanics in sort of exploring processes in thermodynamics, for instance, which are characterized by, infinite degrees of freedom, random behavior of individual particles. But these tools enabled us to sort of develop a precise understanding of the evolution of these systems. Now, what he said, however, was that there was a big middle region between these systems of simplicity and disorganized complexity, which he called systems of organized complexity, where we are talking about finitely large systems and non-random interconnections as well as feedback, right? These were the characteristics of these systems. And his sort of prediction at that point was to say that the next 100 years, he said this in 1948, the next 100 years would be when science made strides in understanding systems of organized complexity, and that this would lead to insights in biology as well as social sciences. Now, standing in 2020, we can say that he was quite prescient in what he said. Mathematics is deeply embedded in biology now, and we are also seeing it increasingly used in the social sciences. Now, once after the characterization by Weaver, the great urban theorist Jane Jacobs categorized cities as systems of problems in organized complexity. And ever since, her writing on this subject, there was a sort of an explosion of work in trying to explore social and economic processes using, simple models, as in physics. I'm going to speak about one of these models right now, which was a model on segregation proposed by Thomas Schelling. This was a model proposed in 1969 when Schelling was trying to explore this question of why American cities were so segregated between African Americans and whites. So what he proposed was a simple structure. He proposed a simple two-dimensional lattice. Think of a chessboard with squares, where each square represented a housing unit, right? Now, in this square, or in this lattice, you randomly distribute two kinds of agents. Okay, you have, let's say, blue and black agents. Now, blue agents have a preference for living with other blue agents. Red agents have a preference for living with other red agents, right? And what he said was that if we were to randomly distribute these agents across this lattice and allow agents to move uh, at each period of time, then he said that we would see segregation as an emergent phenomenon. Now, the only basis that the agents would use to make a decision on movement was what was called a tolerance limit or a tolerance value, was that agents had a tolerance value, which was defined as the fraction of their neighbors that they were willing to have who were of the other kind, right? And what he found was that when agents made decisions on where to live, segregation immediately was a emergent and a persistent phenomenon. Now, for agents at a very sort of low tolerance level, this is not, surprising. It's a trivial result that, if agents have low tolerance, then naturally they would just bunch with their kind, leading to an emergent sort of segregated outcome. But the interesting finding that he had was that even when agents preferred to live in mixed neighborhoods, when their tolerance was over 50%, which is to say that they were willing to live in neighborhoods where over half their neighbors were unlike them, even then segregation emerged and persisted. So clearly there was the disconnect between the micro motives of the individual and the macro behavior of the system, and that segregation was clearly an emergent phenomenon that told us nothing about the underlying behavior or the underlying beliefs of the agents. Now, this was actually quite an insightful finding from a simple sort of model that I just described. And it sort of, nuanced the findings from sociology, where we talk about in-group and out-group, where we talk about homophily as explanations for segregation. Well, this said that, while individual, preferences are a part of the story, they do not tell you the full story. It's the interactions of individuals in the context of a spatial system that produces the emergent sort of segregated outcomes. And so, even the use of such a simple device sort of helped us get at something more fundamental that might be occurring there. Now, since this work, there's been a plethora of work that has emerged on using these kinds of models to explain voting behavior, migration, riots, and the field of sort of mathematical sociology really took off after that period. The one other, sort of example that I wanted to present to you was on scaling in cities. Again, I spoke to you a little bit about, the work that we did in Srirangapatna and the sort of, um, interest that I had in exploring the various dimensions of a city. One of the ways in which cities have often been written about, this is more true of literature than in the science, is the notion of the city as an organism. Now, this is, of course, a very metaphorical way of talking about cities when, in literature. But the question is, can we actually think of them as organisms? Now, what does it mean to think of cities as organisms. One of the ways in which we can do it is to sort of think about how cities change with size. Now, there are well-established laws in biology, for instance, where we know that uh, the pace of life of an organism scales in a power law of the size of the organism. So what we see, what we sort of notice is what we sort of know about this is that there is a 3/4 power law, which basically tells us that the energy required by an organism per unit mass reduces as its size increases, right? Now, one of the things that was done in the early 2000s was to say, well, if we think of cities as organisms, can we find, you know, uh, similar behavior here? And so what was done was a bunch of data on very different attributes of cities was taken and seen how it sort of scaled with size. They looked at things like uh, infrastructure growth, road length, street lights, hospitals, schools, etc., as well as socioeconomic factors like GDP or income or innovation or crime, and they found results that suggest that there are three university classes in operation here. One was when there was a superlinear scaling, which is to suggest more than proportional growth with city size. And this superlinear scaling was found to occur for certain kinds of outcomes, like, for income growth or for innovation as measured in patenting activity or number of crimes, which represented social or economic interactions between people, right? On the other hand, they found that infrastructure represented a very sublinear scaling. So, for instance, the length of roads, represented a less than proportional growth with city size, which again sort of speaks to the economies of scale that are often spoken about in the context of cities. So clearly, there seemed to be something that was happening here, which was also uh, there was a theory proposed of urban scaling, or one theory proposed of urban scaling, which sort of says that the emergence of these outcomes can be predicted by a theory which models cities as complex networks of socioeconomic interactions and infrastructure subject to budget constraints that balance incomes as well as land costs. And these outcomes are seen as emergent in when cities are modeled in this manner. One last sort of thing that I just wanted to show you was that while there has been a lot of talk about universality in these kinds of outcomes, when we look at Indian data, for instance, while there's a lot of agreement um, on a lot of parameters between Indian data and what's observed globally, there was also significant disagreement. So for instance, when we looked at crime in India, we found that crime, while in other parts of the world, especially in the Europe and Europe and the United States, where because data is available, these studies are much more easily done there. In India, we found that crime, for instance, showed a significantly sublinear scaling when compared to superlinear scaling in other contexts, and this raises questions of why that would be. Is there a difference in the way in which Indian cities are socialized, for instance? Are the pre-modern sort of relationships in terms of gender and caste driving some of these behaviors? So what it does is that, some of these methods also help us sort of draw or delve into deeper questions about what might be yielding some of these results. While the theory might suggest that a certain thing ought to happen, clearly the nature of urbanization might be very different in different parts of the world, and that any theory that is going to explain this universally has to sort of take some of these aspects into account. Now, finally, I just wanted to give you these two examples as a flavor of how mathematics is being used in trying to explore social and economic processes across many different contexts. One of the things that's also important is that we need deeper sort of conversations between mathematicians and sociologists and economists, because one of the things, or one of the debates that sort of often we get into, which I personally don't see the value in, is that the use of mathematics as a tool to understand some of these phenomena somehow negates the use of other more qualitative or other methods that have been in use over a period of time to explore this phenomenon. I think it's important to sort of say that these kinds of methods, whether it's from statistical mechanics, whether it's computational methods, whether it's networks, are just additional ways or additional tools for us to look at problems. And at the end of the day, the value of a tool is, is really in its ability to generate models or predictions that can be used. So I certainly, and many others certainly see these as complements in trying to understand the societies that we live in. These are complicated, complex phenomenon, and we need a variety of perspectives and that we bring to the table to understand these phenomena. So a greater conversation between mathematicians and others who've been working on these questions for long periods of time will be essential not only to generate much richer research in this area, but also in a country like India to inform policy making on what are some of the most critical questions that face us. With that, I want to thank you so much for this time. I really appreciate it.
Yeah. Thanks, Anand, for the talk. And then we just move on to Professor Damani, who will be talking about mathematics for society. And Professor Damani is a faculty member at IIT Bombay. He has research interests in so he has diverse research interest in systems thinking and dynamics and the interface of technology and development. And he has guided development and assessment of farm assessment index. So it's a holistic composite index that takes econometric, environmental, and social factors into accounting for evaluating farm systems. So the Jal Tantra developed system that he has developed under his guidance is used by engineers of Maharashtra water supply and sanitation design and optimization of rural pipe networks. And he has engaged with like several voluntary organizations, NGOs, and people's movements in the past. Okay, over to Professor Damani.
Thanks, Prathamesh. My slide is visible, and is my slide there?
Yes, sir. Yes, sir.
Yes, very visible. Yes, very visible.
Okay. So, topic I've been asked to speak on is mathematics for society. Now, mathematics is the language of all of science and technology, right? And in fact, all of economics also. So in that sense, almost everything that is being done about society, all aspects of society involve mathematics, and there would be innumerable examples and way for mathematicians to contribute. So the real question is not what mathematics for society, but many people wonder as a student or faculty that I, as a mathematician, how do I contribute to society as a mathematician? That's the question, because given my own discipline, whatever group theory, community algebra, this or that, how do I contribute? And so the answer, of course, really there is no answer I have. Other than that, everybody has to discover their path. And I will also briefly talk about my journey. But main thing is, that it has to be an interdisciplinary effort. And like just now it was shown also how mathematics can be used in any setting in that sense. And in this context, I will also talk about two courses that can be introduced in any mathematical department. In fact, that will be the main point of my talk. What can we teach students also about mathematics and society? So our social, first of all, very briefly, that just there are so many dimensions. Right? A mathematician is an academician, a researcher, a citizen. And so we have towards the society, we have duty in all of these roles. And when we interact with society, or to say what do we do for, when we say for society, so what can one do for the society? So there are different modes of engagement, different needs, like what's called seva, sangharsh, and nirman. So seva is service in any day-to-day role, any helping anybody. There's any time of disaster, giving money, whatever. There's so many different ways that every citizen, of course, is engaged in and as per the need. Nirman, the building, the construction, is about building things that last. So whether it be systems, processes, institutions, right? So we had Tamil Nadu Science Forum, Kerala Sastri Sahitya Parishad, writing textbook, writing popular book, popularizing science, well, so many generating content in Indian languages, all of it that last. And finally, the fight for justice, because all of it is, despite so much technology, so much development, the development has not happened. And so mathematician we are also public intellectuals. We have a special responsibility, and because we understand logic, we understand different aspects of any problem, that to talk about what is the right thing. And that brings the question, like, should mathematicians be engaged in politics? So and is talking about any of these issues of justice, politics. The point is, politics is nothing but attempt to influence policy, or in that sense of politics where one is trying to change polity. That's where it's a responsibility on us as a public intellectual to speak up, whether it be issue of corona lockdown or AI for surveillance or NRC or any topic, and of course depending on one's background and interest, any topic of the day or anything that's needed for the long-term welfare of the society and the large portion of the society. So this is sort of the very broad context in which different people will find their mathematics in different parts of it. Okay, and of course, for, like I said, citizen, mathematician, and academician, but these three roles, so this 3x3 matrix, everywhere it will happen. But just I have highlighted the sort of the diagonal part of it. That's more important. Okay. So coming to this now, thinking critically about social issues. That's what I say is one of our responsibility as a public intellectual. And particularly for mathematician, we have many tools. That is that of formal logic, probability, statistics, modeling. We just saw many examples of modeling. So that we are equipped with and can bring to the problem. But, and especially in this modern age with so much fake news and infodemic and misunderstanding. But it's not about fake news. Like there are other forms, subtle forms of unscientific reasoning in the name of nowadays, especially big data, machine learning, and these models can be misused in so many different ways. So it becomes our responsibility to tackle at least some of it based. So here is now one example, and this critical thinking that I'm saying has to be at different levels. So for example, this is a headline from some, in fact, article like 10 or 15 days back maybe, that an algorithm that predicts criminality on based on a face. So it looks from a picture, it tries to predict criminality, and it sparked a furor. And thousands, over 1,000 scientists released a letter to denounce it. So that is in this context, one can say scientists were carrying out their duty. Sorry, my screen is not moving. Why is it? Just 1 minute. Why is my screen is not changing? Sorry, just okay. So more than 1,000 scientists released a letter. Of course, the first level of their objection was that this algorithm not based on sound scientific premises and methods, based on whatever the technical details that were given in. So that's obviously something that all scientists must look for in any problem. And then they further went on and they said that the data that has gone into building these algorithms is biased, and they're of course racially biased, and therefore the predictions will also be biased. So this is obviously something that all of us do or must do, especially now that the AI is pervading, AI and machine intelligence is pervading the society. But it also raises a bigger question. Suppose the data was not biased. Suppose most people or a number of sociologists agreed that the data was fair, it truly represented the prevalence of the crime in the society. Then would such a research be acceptable? So I think that is that's the question that we should also ask. So what kind of society do we want to live in, where we try to predict a person's future, person's crime record based on their face? And that's a choice that we have to make, or even when mathematicians contribute to a debate, we have to be aware of what questions are we asking, what questions are worth asking. So anyway, coming back, based on this, what I propose, something that can be done in mathematics department, is a new course on critical thinking. Main point here is that it should be completely based on real world examples. So these are some of the content based on my own background, but and what I find will be widely applicable, but anyone can choose from their own. So formal logic, propositional logic, predicate calculus, then the structure of scientific theory, issues of falsification, how to test how to propose and test theories and fallacies of testing, then probability and statistics, correlation and causation, and relation between them. We just saw certain simulation modeling examples in the previous talk, game theory, and also, the issues of today, like I said, how visualization can be misleading, perils of big data, biases of machine learning, publication biases, etc. For my own course, I am this time going to use these two texts as a references, understanding scientific reasoning, and at University of Washington, there's a course called Calling Bullshit, which is just coming out, the textbook for the same. But obviously, so one picks some subset of this or a different sets of topic based on one's own interest. But I think this is something that should be part of every mathematics department, because mathematicians, mathematics students are particularly suited to talk about, to be taught and to talk about critical thinking. Okay, sorry, again my screen change periodically becomes very slow. I don't know, I should have used a PDF maybe. Okay, so suppose we do all of this and we do critical thinking, the question still remains, where do we apply this thinking? Like, what questions do we ask? So which society, which problem we look at? So here are two examples. These are like two puzzles like thing, and then one of them says there are n petrol pump on a circle, and a racing car has to go around collecting petrol and find the first pump where the empty racing car will complete the circle. The other one is about a village water tank where some input-output pattern is given. Water comes only few hours in the morning, few hours in the night. Of course, water use happens throughout the day. So question is, what should be the size of the water tank? That ESR is the elevated storage reservoir. While driving around, all of us see those water tankies. Now, it turns out that these two problems have exact same mathematics behind them. The solution of them is identical. So how do we phrase what problems interest us? How do we phrase problem even when making exercises for our own domain, or what examples we choose? Matters, because what kind of background literature reading we do, what kind of variations of this problem we work on, and while at this point they have identical structure, as we play with the variation, the structure will diverge, the data required will diverge. So that brings me to my second point, which was that where do we apply this critical reasoning? And about understanding, for that we need to understand reality and societal problems firsthand. So for most of us are really far away from reality, whether it not necessarily just in academia, even if whatever job we are doing wherever outside academia. And so we are like, when I say reality, I mean reality of vast masses of India, vast masses of the country or the earth. And in fact, often our view is not even just this far away, but it's a second-hand or third-hand view based on by reading and writings of those who themselves are far removed from the society. So if we want to do something for society, we have to go closer to it, right? So there I propose a second course that's called Mathematics and Society Supervised Learning. And really the main requirement for the course is that leave the campus and you have to go to the society. It's like any other regular course in a semester, and say 5-6 days of field work over a 4-month semester. That's all. So the only main requirement is leaving the camp. Problems you choose will again depend on the advisor and the student's interest, and whether it be in the area of energy, water, farming, agriculture, anything, right? Any aspect you go and pick, and then part of it will look for data collection, analysis, and design. So it will require introduction to fieldwork, multi-stakeholder, like going to how do you approach people in a humble way and respectful way. Identification, fieldwork, problem collection, data collection, and then bringing formal analysis to the problem. So one of our contribution as a mathematician is to bring formal analysis to the problem, structuring the problem, structuring the solutions, comparing the solutions, preparing a report, and then giving feedback to the stakeholder. for the same problem, different mathematician or different technologist will look at it from slightly different angles and bring in different solutions. So it's also just it's as much this course will do as much for the problem, but more for the students or the faculty themselves. And like I said, this has to be interdisciplinary. Depending on the problem, one may partner with other people. So that's very briefly the two courses. Some variant of this is either being taught at IIT Bombay or will be taught, like we teach a course called Technology and Society, which is in the similar format. And in fact, as a partly our work before that and partly after this Technology and Society course, I have also visited hundreds of rural water schemes, and we have a big drinking water group here where we understood. So of course there were social, political and financial issues in why there was a widespread drinking water crisis in areas around Mumbai. But there are also technical problems we identified. We formulated it as a mixed integer nonlinear programming. And then we built an optimization engine called Jaltantra. That was a PhD from one of my students, Nikhil Huda. And of course, there are like literally, I mean, some 30-40 students over the years have contributed to this project. So main point of this course or this was that spend some time outside campus, then mathematics or the required technology will follow. Then just get engaged with the society. And in general, at least spend a day or two per month with whatever, any outside entity, whether it be a government department or research lab or NGO or CSR entity or whatever. Next slide. Sorry, my slide change always takes time. Okay, so very briefly, this has been then our framework. This is the 2-3 of us faculty member in the drinking water group, where there is a grassroots level work, problem definition, quantification, understanding. From there, we brought a systems level analysis. So single villages. So this is in the context of drinking water, single village drinking water scheme, multi-set scheme, water set program, NREGA. We studied some of this, studied government document, developed the best practices and discussed with block administrator, Jila Parishad, Gram Panchayat, BDOs, local colleges. And then brought in the modeling, simulation, GIS, decision support, all of the tools, the technical tools to the problem. And finally giving planning input. So of course, this has been a work of a slightly bigger group over many years, over almost a decade. And then providing our input to whoever may listen. And that's of course always a struggle. So as you see, important part here was going out into the society. The more technology or the structure heavy we become, the far away from the society we are. So the work has to be done at all levels. Either just one or the other does not work. Next. Okay, so these were the this is the part which I say what has been my journey. But I would just talk about one more course that I was not saying can be should be taught, but maybe now that the previous speaker talked about complexity and the social system, so that's pretty much what it was. The course I teach is modeling and simulation for development or system dynamics. Okay. So generally, most of the decision making is very problem focused, and we believe that we'll take some action, whether it be, if it's in case of a corona, we will take a lockdown. In case of corruption, we will do demonetization, and then the situational discrepancy will disappear. And we forget that sorry. I'm sorry for, I think I should have rebooted my machine.
Is there anything we can do?
Just few more. Why is my machine stuck? Okay. Or maybe I should just escape and just give me 10-20 seconds. So I suspect. Okay. Oh, okay. Okay. So maybe antivirus has started running on my machine or something. I don't know. I'm sorry. So what we ignore is that there are other players and they have other decisions and they take other actions, which was not part of our original plan. Like I said, in context of Corona, we have just forgotten about migrant worker and how they would like to act, or in case of demonetization, how again the entire society, how will the immediate day-to-day needs of the society will be fulfilled. So that there is a feedback from our action that we haven't thought about, and how that goes back and changes the game, and it changes the situation which we were trying to correct. That's sort of the main goal of the thing. It's also simulation. So this work, the particular methodology, system dynamics. I mean, just now we talked about complex system, the previous speaker. So that word model, the phrase limits to growth came out of in the early 70s of a model made by J. Forrester at MIT, and this was about so this was early 70s, and when environmental movement was taking place, and this phrase became popularized of how eventually the non-renewable resources will lead to limit growth, will limit the growth. So this is a simulation model, the large scale simulation model. And so anyway, so I think I am out of time. So basically what it showed was you can lot of scenario, lot of things you try and all, nothing works unless we limit on the consumption side also. See, self-imposed limits combined with a judicious use of technology only can lead to a sustainable equilibrium. That was the main message. So, really sorry for the, anyway, I think I'm done now. So just and also I think constantly I'm also getting these admit people. So maybe, okay, so anyway, so maybe I will skip this. This is just one more example that all the three courses that I have talked about are about real life issues. So we pick newspaper stories pretty much every week in each of the course. One of the courses, of course, about going out. And so I think I'm out of my time, so I will skip this. But essentially, when we discuss equity and efficiency, then these discussions typically happen in a static setting, while there is a dynamic feedback that money begets money and the rich gets richer, and education, healthcare, and all, get non-distributed. And I think that was again pointed out. So that is, I think that brings me to my concluding slide. If I can read, or I think next speaker can now just come in, because yeah. So essentially.
Shall we move to the next speaker, and can we just discuss some of this in the question answer session?
Yeah.
We're out of time right now.
Okay, yeah. So so in summary, what I said was that mathematics has to be interdisciplinary, and one has to go to the society or to understand it. If you want to do something for society, and lot of the tools of logic, probability, statistics are directly relevant. And then I propose 2 courses. Thank you.
Thanks so much. And so we just moved to the next speaker who will be talking about what it means to do mathematics in society. And this is by Tathagata. And Tathagata Sengupta is a reader at the Homi Bhabha Center for Science Education, which is a part of the TIFR family in Mumbai. And Tathagata is primarily trained as an algebraic geometer, and he's trying to understand the interconnections between mathematics and society, and especially in an Indian context. And as he says, he's trying to understand this problem called as mathematics, education, and research. Over to Tata.
We can't hear you.
Yeah, sorry. Am I audible now?
Yeah.
Yes.
Yeah, and is my slide visible?
Yes.
Okay, so thanks for asking me to take part in this discussion. I wanted to begin with one of the most recent episodes of what we might call as mathematics meeting our society in the recent times, and I'm talking about the COVID-19 pandemic and specifically the role that mathematical modeling played in dealing with the pandemic, like both the earlier speakers kind of mentioned in their presentations. But I wanted to qualify. So I want to look at this meeting point in a little more qualified sense. So I want to sort of think of it as a point where our metaphysical mathematics meets our physical society. So before we go forward, let me just clarify what I mean by metaphysics. So the more the commonly accepted notion of definition of metaphysics is the branch of speculation which deals with the first cause of things, whereas actually the more historic and perhaps the more factual definition of metaphysics is should be taken as the way that term was first used as at least based on what we know. This was used in the context of Aristotle's work, where his volumes of work that preceded his works on physics were called metaphysics. And so literally the term metaphysics meant that something that comes after the physics. And this included his mathematics, logic, and so on. So now the point I want to make here is that these are two fundamentally different ways of looking at metaphysics. So the first way sort of talks about metaphysics as if it's the primary thing. And physics emerges out of it. Whereas the second way begins with the physics, and then metaphysics comes in after the physics to sort of, logically make sense of what we observe through our physics. And that is the later sense is is the sense in which I think of mathematics as metaphysical. Because that's one of the main central roles that mathematics plays. Now, so getting back to sort of, the question of what it means for metaphysical mathematics to meet physical society. So here is sort of a visual attempt at capturing that idea. So so in the middle of it, we can see sort of an example, a snapshot of one of the numerous kind of mathematical models that came up during the pandemic. This is one example where the authors are suggesting a certain extended period of blanket national lockdown with the mathematical claim that in all likelihood this would control the spread of the infection and so on. So the reason I call this as metaphysical is because at the fundamentally what these kinds of models involve is this kind of a move where we replace a real human being made out of flesh and blood with a real history, with a real, within an existing society, with parents, with children, with families, with friends. We replace such people with metaphysical dots. So that's why this kind of mathematics should be actually seen as a metaphysical kind of mathematics. And then you have sort of the rest of the picture shows the physical reality, the physical society. And I've deliberately split it up into two sides. I mean, on the right side, let's say it tries to show, let's say 80% of the people of our country, the working people of this country. And we all have seen what kind of realities they have to face with after the lockdown was imposed without any prior preparation or any prior notice. On the left side would probably be the remaining 20% of the society, and this includes people who were lighting candles and banging vessels and throwing flower petals from the skies to celebrate. I am not sure exactly what. And these are also the people sort of who were asked to chill at their homes and work from their homes and so on. So the point I'm trying to raise is twofold here. One is we have seen the kind of role that this piece of metaphysical mathematics could play in sort of this unfolding kind of a reality. The other thing is that we also should not forget that most of us who are in this meeting today, for instance, belong to the left side of the picture. I mean, okay, I mean, I can't speak for everyone, but I'm assuming that most of us do. And also, I'm not saying that all of us lit candles and banged vessels, but like what I mean is that our socioeconomic location places us quite squarely in the left side, and that side is where the mathematics, this mathematical production is coming from. And often what we as mathematicians tend to do is to say that is to basically hide the objectivity of this physical reality under the carpet of the objectivity of the metaphysical activity. We tend to say that, oh, since mathematics is objective, so it doesn't really matter who comes up with a mathematical theory and so on. But it doesn't really work, in my opinion. Anyway, so what I really want to focus on is sort of this relation between physics and metaphysics, which I want to, I sort of see it as a power move. And um, the I mean, every physics needs a certain kind of metaphysics. So I'm not trying to criticize that, but I'm more interested in sort of the relation that this metaphysics in turn forges with its physics. And there are three broad ways in which we can judge those relations. One is what it does, what that metaphysics has to say about, let's say, something like critical reasoning, what it has to say about the concept of matter and therefore material reality, and what it has to say about people's physical experience and the reality that they perceive, let's say, from through their sense organs, right? So I think the last part of this slide probably is not visible in your screens, but I just had a relevant question at this point for those of us who are practicing mathematics. I mean, for instance, what I really mean is we could all ask ourselves this question that what do we consider as a higher truth? Do we consider the actual people on the streets as more true, or do we consider the dots in our mathematical models that are supposed to represent them, do we consider those dots as more real and more true and more meaningful, right? So answer to that, I think, should tell us all what how our metaphysics is related to our physics. And there are two questions, there are two reasons why I'm raising this. One is this relation between our metaphysics to our physics determines the kind of philosophy of knowledge that we knowingly or unknowingly subscribe to. The other is that this kind of splitting of a metaphysics from the physics is not happening out of the blue. It's not happening just as a theoretical move. There is a real material political reality that operates in society that determines such moves, and that later part is what I want to focus on for the rest of the presentation. And this is where sort of, so this reality, this political reality in our society is, I mean, one of the centerpieces of this when it comes to the kinds of questions that we are trying to raise is the politics of knowledge in this. So that is what I'm going to sort of focus on. Now, the politics of knowledge, and let me also say that a couple of things that, I also think that, when we talk about politics in society, we should also think of it as a dynamical system. So in other words, what we are seeing today has a whole long history behind it. Things are not happening just on their own. And the other thing is, there are like different kinds of philosophical ideologies that are in clash. And out of this, I wanted to focus on the hegemonic ideology, the hegemonic philosophy. And in this case, particularly when it comes to the intellectual classes of this country, the direct inheritance that we have, philosophical inheritance, is that of the Brahminic classes, that of the Brahminic philosophy, or what we might also call the Vedic or Upanishadic philosophy. So I'm going to focus more on those doctrines. But this is not to say that these are the only philosophical schools in this country, thankfully. But okay, so the first aspect of the politics of knowledge is the relation between knowledge and money. So for instance, I mean, we are all familiar with, our own mathematical experience as mathematicians, let's say, where, honestly speaking, many of us really believe in sort of, the mathematical world as the real world, right? I mean, that is the well-organized world of mathematics is something that is the ultimate truth. And many of us are actually, not very happy with the kind of messy practical reality into which we are born, right? We kind of feel captive in it. Right, so that is so this is what we can call the idealist's crisis, right? So on the one hand, we have this idealized world of mathematics, but on the other hand, we can't ignore this thing, the actual realities. So when, for instance, when we get hungry, we can't eat geometric donuts, right? We need actual food. When we are thirsty, we need actual water, and so on. So that has been sort of that is one of the questions we should ask, that this kind of idealism, particularly that mathematicians are used to doing, so efficiently, where is their non-ideal, or let's say material money coming from? Where is the money coming from? So here is an example from the Upanishads, where Yagyavalkya, there's this story of Yagyavalkya is one of the central philosophical figures in the Upanishadic school. So Yagyavalkya comes up to Janak, and the king of Videha, and Janak asks him, why are you here? Is it because you want hair splitting discussions, or do you want cattle? And Yagyavalkya responds that, oh, I need both. And then there are this, descriptions of how Janaka goes ahead and sort of, rewards him with various kinds of gifts in return for his wisdom. If you look at the Buddhist scriptures, you can see detailed descriptions of the property, the material property owned by the intellectual classes, and most often in the form of lands gifted by the kings in return for their spiritual ritual services. Buddha himself talks about the Brahmins, wealthy Brahmins living like the proper landed aristocrats in sort of, fortified towns with elaborate security apparatus and so on. So one of the relevant questions, for instance, we as the Indian mathematicians of today could ask is, where is our nth pay commission paychecks? Where are they coming from? And why are we being paid so much amount of money? The other feature of the politics of knowledge that I wanted to point out is sort of the alliance between knowledge and the power of the state. So again, here is a excerpt from the Upanishads, which talks about how there is nothing that is higher than the law. And then it goes on to say that a man who speaks the law speaks the truth. So here you have a philosophical doctrine claiming that truth is true as long as it does not contradict law. And law, by the way, law here does not refer to nature's law. Law here literally means the law of governance, the law of the king. So it is not surprising when several historians, Indian historians, have pointed out that the conflict, the so-called conflict between the church and the state that we are used to seeing in the, let's say, the European history, that is not a thing when it comes to Brahminic tradition. So in other words, in the Brahminic tradition, the priestly class and the state power, they have always been in hand in gloves. I mean, there hasn't been a lot of conflict between them. And the priestly class, we should remember, is sort of the precursor of the intellectual class as we understand it today. So what I would want to claim is that this reality continues right up to today, right, when we are having this meeting, that the Indian academia, there is no conflict between the Indian academia and the Indian state, fundamentally. Here, I mean, in this point, I actually wanted to specify something specifically about mathematics. So across the world and across, in fact, time and space, across histories and across geographies, we can see examples of various kinds of totalitarian regimes getting quite anxious about natural sciences, right? So for instance, if you look at the Brahminic law codes, you'll find like n number of sanctions on when it comes to medicine as a science, right? So for instance, Manu forbids Brahmins from touching corpses because that will contaminate them, and describes the physician as impure and so on and so forth. But you don't see similar kinds of anxiety of the state powers with mathematics as a knowledge system. In fact, it's quite the other way around. So for instance, Edward Frenkel in his book talks about his experience of growing up as a mathematics student in Soviet Union. And he describes how under the Stalinist regime, while several natural scientific disciplines like linguistics, genetics, etc., were had to face with various kinds of sanctions, but somehow mathematics and theoretical physics were what he calls oasis of freedom. So it's curious to sort of try to look at what kind of specifically what is the nature of this alliance with mathematics as a body of knowledge and the powers that rule the people. I'll not go into too many details, but like again, kind of question I think that is relevant to us at the current times is, for instance, we could ask ourselves, when was the last time we heard of Indian mathematicians standing up to the power of the Indian state as the community, right? The other aspect of the politics of knowledge that I wanted to bring up is the question of education, and one cannot talk about the question of education in the Brahminic tradition unless talking about the sort of the prevalent practice of looking at knowledge as something that is like a treasure, that is something that is secret, something that needs to be protected and preserved and so on. So for instance, Manu quite clearly asks the Brahmin not to waste his knowledge where there is no merit or wealth. So for instance, he says that even in dire distress, a teacher of the Veda should rather die with his knowledge than sow it in barren soil. You have the example of Bhaskara basically refusing to use algebraic notation in his algebra textbooks, and the reason he gives for that is that he sees algebra, and quite rightly so, he sees algebra as something that gives expression to what he calls hidden numbers, and therefore he concludes that therefore algebra is for the slow-witted, and therefore that has got no space for his mathematics or his mathematical texts. So again, the kind of related question we could ask ourselves today is how do people who are outside of these walled institutions, these research institutions or educational institutions inside where we do our mathematics, how do people outside of this country, outside of those institutions, how do they look at us? I mean, what relation do they feel with us? Like, what do they think is going on inside? Right. The last, in a sense, broad feature I wanted to sort of bring up is the question of the relation between knowledge and the labor, and specifically the labor of those who are exactly excluded by this knowledge system. So here is a quote from Prafulla Chandra Rai, and I must say that like these quotes are sort of, they are not cherry picked at all. I just had to pick some random samples because of the for the lack of time. Because of the constraints on time. But you can find these kinds of examples everywhere in these kinds of texts. So Prafulla Chandra Rai in his book on the history of Hindu chemistry quite elaborately describes how the caste-based the caste-based separation between manual labor and intellectual work, how that led to what he calls the death of the spirit of inquiry, and therefore that of the experimental and inductive sciences in this part of the world. So again, the question we can ask ourselves is, what connection does today's Indian mathematician have with those professions that involve hard physical labor, right? So this was sort of a very quick run through a very long and complicated history. But coming back to the present, let's take a stock of where we are after all that, given all this history, where are we today, right? So here is sort of a snapshot of the composition of our official intellectual class. So out of across the 40 central universities in this country, 95% of the professors belong to what I want to call the leisured castes. I mean, the usual phrase used to describe these people are the general castes, but I wanted to use this particular this phrase because I want to highlight the fact that these are the people who live on necessarily on the labor of other people. So I want to call them as leisured castes. So 95% of the professors belong to these leisured castes. 93% of the associate professors belong to these leisured castes, and all of us honestly know that this is across all departments, and we know for sure that if we look into sort of specifically mathematics departments, the composition will be even more skewed. And this is when sort of the proportion of the same leisured castes in the total population of the country is not much more than 30%. I mean, it's around 30.2% or something like that. So that's where we are. I mean, this is sort of one of the recent examples of how the metaphysics determines the fate of physics in Indian science. On the left side, you have example of scientists who visit temples to ensure, as which they claim is part of their tradition, quote unquote, to ensure that their physics works. Whereas on the right side, you have the example of a student of science who called out exactly this kind of metaphysics and the role that it plays, the destructive role that it plays in the practice of scientific knowledge, material scientific knowledge in India. So, and we know, those of us who have followed the recent incidents, recent by recent, I mean, over the last few years, we know that these two sets of people have very different fates in our academia. So I wanted to conclude with a question. When we are talking about the Indian academia, and specifically when we are talking about the Indian mathematical establishment, this seems to be, I mean, if this history is true, then this seems to be a structure which is built, first of all, built on the foundations of the labor of people which it excludes historically, and then it has its closets that are filled with skeletons of people like Rohit Vemula. Rohit Vemula is not just the only person who had to give up his life because he had to stay true to what he believed in. There are many other such people, and our closets are filled with these skeletons, right? So if that is the case, then for the sake of rationality, the question I wanted to end with is, why should the common people of this country trust such a violent academic establishment when it comes to dealing with the kind of existential crisis that these people are today faced with? So I wanted to end with that. Thanks a lot again for asking me to speak.
Thanks, Tataf, for the talk. I mean, yeah, insightful talk. And now we actually have Nirja, the next speaker is. So Professor Nirja Sahasrabudhe is an assistant professor at the math department at ISL Mohali. So she primarily works in probability theory and is interested in understanding the interplay between structures of higher education and society. So over to Nirja.
I think Tathagat has to stop sharing his screen so that I can share my screen.
You can force me out, like, I mean, force
Yeah?
my
Okay.
presentation out. I think that's what I did to Om's presentation.
Okay, is this visible?
Yeah.
Okay, thank you, Prathamesh, and thanks to organizers for inviting me to speak here. Uh, okay. So I'm going to focus on the gender aspect of this discussion on mathematics and society. And in doing so, I think I'll go back to some of the things that Prathamesh raised in the beginning in his introduction. I'm going to represent the point of view that the gender question in mathematics should be seen in relation to the socio-cultural context in which mathematics is practiced. But let's start at the very beginning. Why are we raising this gender question? Because there are very few women in mathematics as compared to men. And why is it so? It's because of this stereotype that exists. Is it only because of this stereotype? And if yes, then what are the processes that have led to the creation of this stereotype? There is also an alarming dropout rate at various levels among women in mathematics or in sciences in general. And I'm not going to give out any statistics here, but and I'm going to stick only to qualitative arguments. But those of you who are interested, you can have a look at Niti Aayog's 2016-17 report, I think, on status of women in science among select institutions in India. They only talk about some elite institutions, but it should give you some idea. All right. Just a second. Yeah. To get to the bottom of this, let's first talk about what we see around us and many a times try to ignore it, these are the challenges that women face when they opt for higher education. And some of these hold true for women in science in general, right? I mean, it's not only about mathematics. So the first one is structural barriers that limit the number of women in universities or in particular in STEM. Then there is lack of institutional support and lack of conducive work culture, which leads to this alarming dropout rate that I spoke about. And finally, those who survive often experience this imposter syndrome, which, to be fair, is experienced by both men and women, but women are more susceptible to it, which is this constant feeling of not belonging here. So let me talk about this one by one. So what is the structural barrier that I speak about? So universities and research institutes are isolated islands of knowledge production, and their boundaries are well guarded by merit lists and whatever other forms privilege takes. They are isolated in the sense that they are free of any scrutiny from the larger society, and they are literally walled infrastructures where people cannot just walk in, right? If you want to be allowed, so you're allowed to be part of the system if you qualify a supposedly fair examination. But I mean, can this examination be fair in an already unequal society? And I'm aware that I'm asking for an uphill task because it asks for a complete rehauling of our education system. However, we should remember that this is the process which is restricting women and other marginalized groups from entering the system itself, which leads to propagation of the stereotype, right? The second issue is the lack of institutional support. So in her talk at IISER Mohali and a TED talk at IISER Pune, I think, Professor Rohini Godbole mentions that there is a lack of active mentoring of female students. And she narrated an incident, a personal story about a senior male professor, presenting her with the less ambitious option because of her gender. Okay. So in the same talk, she identifies various issues at institutional level that should be addressed. So lack of mentorship, lack of role models, dual careers, and the unsaid rules of not hiring a couple. So, well, to be fair, I think some institutes are doing away with such unsaid rules, but wherever it is still in play, it almost always affects women adversely. Right? Then there is delayed recognition, gender-related harassment, lack of facilities like creche, and this last point, I've just added this last point myself to the list, which alludes to the fact that knowing fully well that domestic labor is not evenly distributed between genders, institutions are unwilling to accommodate small things like, you know, scheduling of classes and meetings, etc. Okay, so we have spoken about the structural bias, which leads to less and less women coming into universities and STEM fields, and then the lack of institutional support, which leads to dropping out, right? Because they just simply cannot survive. But is it all? Have we hit the nail on its head and addressed the gender question in mathematics? So what we have discussed so far is aimed at encouraging more and more women to take up mathematics as career and make the environment more conducive, more institutional support and so on. So in other words, we are saying that does the increase in number of women change the course of inquiry that may be androcentric in nature to begin with, right? And it's appealing to say that yes, maybe getting more and more women in mathematics would change the culture of mathematics, so to say. But this leaves no space for challenging or critiquing the existing methodological norms that exist in mathematics. So, I'm just quoting here Sandra Harding's question in her book, is sexism a bias that can be rectified by merely adjusting the ratio of male-female in the university? And in my opinion, the answer is no. And it's related to what we are discussing here, because the mathematics that we do, or the mathematics that we find worth doing, is embedded in the socio-cultural norms of the establishment of power, and women, like other marginalized groups, are outside this framework by design. And this framework, this contributes to what I vaguely called the lack of conducive work culture. So my third point was lack of conducive work culture. And what Piper Heron, who was a graduate student at Princeton with Manjul Bhargav, and she wrote a very interesting thesis. And she starts her thesis with this quote, and she identifies this lack of conducive work culture as oppressive culture of mathematics. And she says that respected research math is dominated by men of certain attitude. Even allowing for individual variation, there is still a tendency towards an oppressive atmosphere, which is carefully maintained and even championed by those who find it conducive to success. So I see this oppressive culture that she talks about as something stemming from the socio-political and historical context of mathematics. So what kind of ideas are we talking about when we speak about this culture? So let me get into that a bit. One of the first things we encounter, which I think Prathamesh also mentioned in the beginning in a way, is this idea of purity. And I believe it is a result, it's the result of this context and contributes to oppressive culture. And in a weird way, this whole idea of purity is used to elevate the position of mathematics. Right? We constantly hear this as students, as faculty, all the time. And it creates a bubble that is not only difficult to penetrate, it's also very difficult to exit. Once you are inside, it's very difficult to exit because you are doing the best of the sciences in a way. And the second thing is, sorry, I keep getting this. Yeah, the second thing is this objectivity myth. So the idea of science being value neutral or objective is perpetuated in the corridors of elite institutions, despite having been challenged by historians and social theorists. And this myth is easy to propagate because mathematics is expressed in formal symbols devoid of any social value or influence. But we should ask ourselves if symbolism guarantees absence of social values. So we should ask if the history of mathematics is merely parroting who did what and when, right? Or is there more to it? So, so historians have argued that social values, interest, preoccupations of a culture, all of these things are reflected in the way they understand quantification and even logic. So it's easier to understand why it would reflect in the way quantification or computation is done in that culture. It's more difficult to understand why it would reflect also in logic. All right. So the big question is now how mathematics we do is affected by dominant cultural groups, and in which way the point of view is androcentric. And I think this line of inquiry is extremely important, and this is what is going to lead us to the bottom of what creates this stereotype of women not being good at math. So in a way, what I'm asking is to reverse the gaze, and I have just paraphrased what Jacqueline says in her essay about science, to say that feminist critique transforms the woman question in mathematics into the mathematics question in feminism. The challenge is that most of us do not even know how to start imagining or thinking in a world where the values as well as authority is not centered around ideas of men, right? And it is, and we are not constrained by those values and by that authority to think in a certain way, to even feel and act in a certain way. So this is not an easy question to answer, but the fact that research is androcentric is not an alien idea. For example, in medical sciences, people have spoken about it, written about it again and again, how research or research questions are motivated by keeping men at center, right? And yesterday, I was listening to a talk by a colleague, Weber, who gave a very nice example about how we understand geometry via compass and so on, because of our Eurocentric idea of science, and all this came from Greeks. If it had come to us through Japan, we would be thinking of geometry in terms of folding papers, right? So it's once you have the example, it's easy to see, but it's not easy to come up with these examples always. Yeah, so I would leave it at this, that it's important to reverse the gaze, and I'll just summarize the points that I made, which is that while institutional support and structural barriers need to, so there should be institutional support and structural barriers need to be removed so that larger number of women come into research and in mathematics in particular, because it leads to inclusivity and diversity in research. But what is also needed is a critique of Eurocentric and androcentric nature of mathematics. And Om talked about having a course about critical thinking. I think it should include these ideas as well. Um, and how does practice of mathematics change if we are mindful of these things, if we are mindful of the context, the political context as well, and the ethical and social implications of what we are doing. So that, in my opinion, is these things lie at the intersection of gender question in mathematics and the mathematics question in gender studies. I'll just conclude this with the references of what I have said in the talk.
Thanks a lot, Nirja. It's a very insightful talk, and yeah, help reverse the gaze. And as one of the comments that came, so I think before basically we just kind of start addressing the question. So this is just a question that I would really want to propose to the panelists: is what kind of education of mathematics, and how do you really see it benefiting the people at large, or at least the mathematics in the current form? What do you think? What exactly would society have to gain from a greater understanding and ability to grapple with mathematics? So, Nirja, maybe, and Tata, Anand, would you like to just briefly comment on this? Yeah.
Sorry, Prathamesh, can you quickly just repeat the question, because I just lost the middle part.
So what do you think society itself would have to gain in kind of learning more mathematics, or ability to think mathematically, or at least however we define mathematics in the current form? So yeah. So does one see any positive influences of mathematical education on society today? So with this question, I'm
Yeah.
sure.
So thanks, Prathamesh. Maybe I'll just get us going. Just a couple of thoughts. I think one of the things I think either Om or Nirja or you mentioned was the fact that, in current times, right, even with COVID and, the sort of everyone now understands what an exponential distribution is and what that means. I think the fact that a lot of stuff, in the news today is presented in a veneer of science, right? So, there is this, any data that that needs to be presented is presented in the form of a graph. There's a line drawn through the graph, and something is being claimed. At the very least, I feel that students should be able to question some of those things, because science is sort of the currency of most public conversations. Whether it's scientific or not is a different question, but giving it this sort of cloak of science is seen to be very important. So at the very least, and I think Om had mentioned this about critical thinking being a very important conception. I think completely, you have to have some base level of filter that students have when they see something. I remember this, graph that the Hindu put out a few months back when there was a coup in Ecuador, where they plotted, number of coup attempts over time versus human development. This was sort of, a set of points that was scattered all over the place. They drew a line through it and claimed that human development has a positive correlation with coups. And, and because the newspaper puts it out and they have this nice graph and they say it, people might actually believe it. And the point is, even the most basic sort of thinking about, what you're even seeing there should warn you that, there is a big red flag, or there are many red flags out there. So, some of these are, fairly basic, and at the very minimum, some sort of statistical reasoning or mathematical reasoning is critical thinking. We have to evolve these courses that, whether someone is going to be a mathematician or not is irrelevant. This is just being a citizen in society. Again, with COVID-19, we see graphs every day. ICMR put out some astounding graphs over the last few months. I think they stopped putting out graphs after one that claimed that COVID would be over on May 16th. So, do we have the tools to ask basic questions of these kinds of presentations of data? And as data becomes more and more prevalent, we're only going to be seeing more usage of this in this veneer of science. So those were just a couple of thoughts that I had.
So I just want to add one thing, that while we can talk about, we should and we must talk about how to take mathematics to society, we should also try to understand how mathematics already exists in society. So people outside formal educational setups, how do they learn certain things, maybe just computations, and where do the ideas of abstraction lie in the society already? I think it is important to also understand that.
Yeah, that's a really interesting point and very insightful. Yeah. Any of the other speakers, would they, Professor Om, who had suggested some speaker questions, as well as Tathagata, who had some strong philosophical questions, opinions on this. So would you please also want to just have any thoughts to share on this?
Yeah, I just wanted to say that, mathematics or any knowledge system, right? Knowledge systems ultimately are created by people because out of various kinds of social processes, right? So, so in that sense, any knowledge system is as crucial or necessary or important as any other knowledge system. And the first point is that we should look at mathematics as something, as a let's say a particular kind of knowledge system within an entire ecosystem of knowledge systems. That's the first point. The other thing is, specifically in today's context, when we talk about mathematics education, I think the history of mathematics education is essentially about, it's one of surplus extraction, right? And we can get into more details about that history, but so for me, that question of how do we look at mathematics education is quite intricately connected with how do we look at the idea of surplus extraction from people's labor. And unless we have an idea of how to unless we have a stand on what we think about surplus extraction per se, I don't think I can even begin to ask that question of, how do I look at mathematics education? Because a mathematics education that is meant for surplus extraction will be fundamentally very different from a mathematics education that is, let's say, against surplus extraction. So there is a prior to that question, is what I mean.
Yeah, thanks for sharing this. Professor Om.
Yes, so I think what you said, if I mean people see the relevance of the method, I mean the kind of questions that are asked, that are taught, I mean the examples like you said get taught in the textbook, and relevance of their daily life, and if the questions that they have, if those questions get a voice in whether it be in education, in politics, so I think once the awareness comes that there is a relation between the picture that is presented in textbook, or whose voice is reflected in the textbook, in the science, in the education, I think that would be that their voice can also have a place. Currently they see it as a two different world. It is just somehow get a degree for certain job, and of course mostly the marginalized people just aiming for, they have no hope of actually learning anything, but they know that that's the only pathway out of their marginalization. But that the education itself, I mean, they can question the education, they can question the existing paradigm. That will happen when their voices get reflected in the examples that is taught, in the problems that are presented. I think that's what should be.
Thanks for sharing this. So coming to the questions, of course, there are many questions that are asked, and maybe I'll just like start with them. And yeah, so one of the questions that was essentially posed to Tathagata is, okay, even if you really think about reservations as like one part of the solution, then often the institutions of higher education are not necessarily supportive. And so when people enter the higher educations, they do often face discriminations of various kinds. So how do we really deal with this question? So this is to perhaps, I mean, any other panelists also, please feel free to step into this question. So yeah. So Tathagata, can you hear us?
Yeah, hi. So the question is what? Sorry.
So the
It's
question
about
is,
like higher education.
yeah, so higher education, so even though people might necessarily come into reservation, but that is not the end of discrimination that people face in higher
Right.
education, right? So that's the question, yeah. So how does
Yes,
one?
absolutely. I think I don't think reservation is by itself is an end in itself. But what reservation does, of course, like I mean, the first reason for reservation is just that, like I tried to point out, people should get their rightful share of every space. And I mean, the entry, I mean, so I have this, like, I mean, this question we face quite often when it comes to, the debates around, let's say, mathematics education, that, I mean, so what is the solution, right? So is the solution that you bring in more and more people inside this structure, and inside these institutions, like, let's say, through something like reservation, and and would that solve things? And my first objection to that kind of a thing is like on that perspective of bringing in people to these structures, because these are not structures that we privately own. So first of all, we are no one to bring people in. In fact, we are hogging too much space inside these structures, and if anything, we should leave some of these spaces, and so that there is equal distribution of these kinds of spaces that is historically due to people. The other thing is, I also disagree with the kind of sort of the inclusion exclusion kind of paradigm that is often used to sort of pose these kinds of arguments, as if it's just a question of inclusion, because I also think that if it were really inclusive, I mean, structures are structures because precisely that, because of the fact that they exclude people, right? I mean, if you have a structure which is truly inclusive, then it will not remain as a structure, right? So if our educational institutions were truly inclusive to the extent that they needed to be inclusive, we wouldn't have these separate kinds of institutional demigods, like the way we have today. I mean, so it is fundamentally based on exclusion, and in that kind of a situation, inclusion essentially is sort of something like a band-aid. But having said so, I also want to mention that I find, I mean, so this question of reservation in educational institutions, I find very similar to, let's say, the question of temple entry that a lot of anti-caste movements have been fighting for a long time, right? So now temple entry, I mean, why? What is the similarity? The similarity, in my opinion, is that when, let's say, subaltern castes are fighting for entries into, temples, Brahminic temples from which they have been historically banned, they are not demanding entry because they want to go and start subscribing to that god from tomorrow. They understand that it's not their god, it's someone else's god. Their logic for temple entry is that if it's supposed to be a public space, it is supposed to be a public space. So if you have entry to it, why shouldn't I have an entry to it, right? So I look at entry into academic institutions in a similar sense, that if it's a public institution, it should be open, its gate should be open for everyone. And then the question of whether that knowledge system inside those institutions, whether they make sense or not, whether we need some other kind of knowledge system or not, people will decide that. I mean, so just because someone is wanting to enter those educational institutions does not in the least mean that they are writing that kind of, they're signing on a contract that, like, I mean, now on this is my god. I mean, that's not going to happen. So having said all of that, I think uh, for the um, for in fact, I look at just, I mean, I would agree with the way Nirja proposed that we should reverse the whole framework of looking at these questions. I also think that we should think of inclusion into let's say mathematical institutions, let's say through reservation or these kinds of policies for the sake of mathematics, if anything, if not anything else, not for the sake of society. I mean, most of our social existence does not really care about the kind of pure algebraic geometry that we people do, people like us do, right? So it doesn't really matter much to people's existence. But what inclusion can do is, in fact, to enrich mathematics, if not anything else. So I think for the sake of mathematics, we should think of inclusion, if not, and not necessarily the other way around.
So thanks, Tata. So one of the other questions is it within the nature of mathematics about the way it is used or misused? So especially when you're trying to model real life questions, or especially when you're trying to kind of model humans. So this is a question that was posed, and any of the panelists, please feel free to pitch into this question. So yeah.
Sorry, can you repeat the question?
So is it within the nature of mathematics, the way it is being used, right? I mean, especially it happens to allow us some physical realities and predict, but sometimes it also drastically fails. And sometimes it can also become drastically unethical. So is it within the nature of math about the fact that there are these outcomes? So yeah.
I think it's not nature of math, but nature of humanity, human beings. So any enterprise we take, I mean, the point again, when it succeeds, when it fails, depends on the tools, but depends also on the participant. So of course, I mean, the issue of the training, so it's more to do with the training than the tool. I mean, the way we thought to always abstract away. I mean, abstraction is the powerful tool, but what all we abstract out, like Tathagat hinted at that, and whether that's important or not, that decision is with the mathematician, not so. If that is carefully, I mean, the mathematician is conscious of what is being abstracted away, then the abstraction per se would not be a problem. And in that sense, and the answers are always, of course, not there, or not everything can be solved in one particular way of doing things. But then like it's being said, the nature of mathematics itself will also change, and different tools will emerge. I mean, different ways of doing mathematics and different ways of reasoning. When we say mathematics, it's about the reasoning, right? So in that sense, mathematics, reasoning, science, they would all be one and the same. And once we become conscious of these issues, the solutions will follow. Whether the same thing will work or something different, you go after the right question, then the answers or the way to go on, the answers will come. Thanks.
Okay, so there was one question I think that just come. So this is addressed to Tathagata, that he was defining the idea of surplus extraction and wants to know what the term loosely means.
Yeah. So surplus extraction. Well, I mean, surplus extraction basically means uh, in the context of economics, it basically means people, you on the one hand you have this huge number of people who belong to the toiling population, uh, who are supposed to put in their hard manual labor on the fields, on the streets, in the factories, and everywhere else. And the economy, as we understand it, uh, since in fact I think post agricultural times, I mean, since like post the time human beings invented agriculture, the economy is essentially based on basic separation between two sets of people. One set of people who are supposed to put in that labor, and then the the fact that by various kinds of through various kinds of apparatus, I'll come to that in a bit. They don't get back the kind of labor, exactly the amount of labor that they put in. So the extra amount of labor is through those apparatuses siphoned away from this set of people to a thin layer of people who are, on the other hand, who I have referred to as these leisured castes in my presentation. So in other words, people who who don't have to put in their own labor for maintaining themselves, and they can live off other people's labor. And typically this is the same class which therefore has a lot of leisure time, and therefore they can get into this kind of meticulous intellectual activities. For instance, the kind of activities that our mathematics requires. I mean, it needs a lot of time, right? The kind of mathematics that we do. So the fact that we have this separation between the intellectual class and the working class, it's based on being able to, one of these classes being able to sort of, in a sense, leech off the labor from the people who are actually putting in the work. And what I was trying to, and those apparatus include various kinds of things. It includes religion, it includes, of course, it includes the state. In fact, historians have argued how that was the very reason for the creation of the first states, in order to be able to manage this surplus extraction. So therefore, the question of the connection between the intellectual class and the state, that if our intellectual class does not feel the need to counter the power of the state, that is a proof of the fact that our intellectual class has no problems with the process of surplus extraction. And if that is the case, then what I was trying to argue is that everything that it does, like this intellectual class, including its educational institutions, research institutions, its bodies of knowledge, etc., etc., it organizes in so as to ensure that the surplus extraction is not disturbed. Because let's say if the surplus extraction is disturbed tomorrow, the first thing that will hamper me as an intellectual is that my paycheck will get stopped. Next month onwards, I'll not get the kind of 7-digit salary that I draw, right? So I obviously wouldn't do anything that disturbs that, and that matters. I mean, but the problem with mathematicians is that they would try to argue that it doesn't matter, because mathematics is ultimately about symbols and abstract things, and has got nothing to do with reality. And that's one of the points that, for instance, Nietzsche raised objections to, of looking at mathematics in that way.
So this was a question, I think, that's addressed to both Nirja and Tathagat. That is, does calling mathematics the purest of sciences absolve us from the problems of society?
Well, the short answer is yes. Yes, it does, and it does. It also creates other problems where you're, the whole idea of purity that I spoke about, and how it is removed from the society, which is not true. It's very misleading to say that, first of all, because it is, like I said, embedded in the socio-cultural norms of the society and the politics of it. So first of all, the claim itself is misleading, and it is very damaging, because Nandan says, that it absolves us uh, from the problems of the society, and it also creates these problems for marginalized people from marginalized groups who come into mathematics, and then there is this wall of purity in front of you, right? Which is extremely hard to penetrate, because you're constantly told that this is the right kind of mathematics. This is what you should do.
Yeah.
So it creates two kinds of problems in my opinion.
Uh, Thanks. And then there is a question.
There is nothing pure about it. It's also a lie. It's not even factually correct that it's very pure. Whatever pure means, but it's even that it's a lie. It's not pure.
Yeah, I think I would agree there. And the presentations here, of course, by Jam, they talked about math addressing social problems as well as critique of some of the models. And so, are there any studies of math that are needed by people in society? So, what kind of math would people find it useful? And are there any studies or are there any ideas that one would have on how to go about it? And this was any of the speakers can feel free to pitch in on this. So, and Professor Om had some ideas. So, would he want to kind of come and address this question?
So, I mean, there are two aspects. One is, are there types of math that are useful? That's one part. But can math be useful? I think there are many different. Maybe Jam should elaborate a bit more on the question. I think it will be useful, because otherwise, in some sense, the question has been answered in the presentation. So maybe he has more in mind. And is it okay if he speaks up for a minute or 30 seconds?
So, is Professor R. Ramanujam or Jams?
You want me to?
Yeah.
Can I say something?
Yes.
Yeah, please do, please.
Yeah. So, what I meant was I was asking for studies. It's one thing for us to decide what kind of mathematics is needed and then go about doing it using models or whatever, and that gets into problems and something that's talked about. Another is actually empirical studies that say, this is what is needed, and this is, certain kind of mathematics is needed for certain, especially people of the working class. Yeah.
So maybe Jam, I guess he has been, since you have been involved with math education and science movement, is probably better. You are better equipped to answer this question than some of.
Okay. No, I didn't mean to
sure.
promote an answer by a
Yes,
question.
I would like
But what I meant was quite a lot of the problems come also because we kind of pre-decide the math and what society needs and look at society mathematically in a particular way. Engaging with people directly, like you were talking about in your field visits, etc., right? Situation on the ground gives rise to particular mathematics then, and I don't see too many studies of that kind, documented studies that we can follow and take up. And so in terms of what to do for math in society, that might be a very concrete way of getting in and doing things for people. So I meant in that sense. Yeah.
Could I say something? This is Jayashree.
Please.
Yeah, I think that, there's good bit of work that's happened elsewhere, and particularly following the critical theory perspective is one huge branch called critical math education, which actually looks at, follows Freirian approach to education, and therefore also math education, which might be something that would be worth looking at. I think to answer the kind of questions Jam raised, and I think there have been small experiments done, very very small, but some things have been attempted. Though a lot of them are critical, but critical in the sense that they're kind of looking at and studying rather than literally doing things. But then, yes, there are, I think, a few attempts at least that have been made. So it will be very worthwhile to look at them. Yeah, that's all I wanted to say.
Can I say something, Prathamesh, on this?
Please. Yeah.
So specifically on Jam's question, so I just wanted to sort of add that a lot of times, right, when we sort of pose this question in that sense, right? I mean, so what is it that we think the kind of mathematics, what does mathematics have to do with society, or what kind of mathematics education should we think society requires, and so on. Somewhere there is a hidden premise in all of these questions, and we probably unconsciously succumb to it, but because we are kind of conditioned in that sense. But the premise is that, like, somewhere it assumes that we ourselves are somehow not part of that same society, right? It's as if we are these floating bodies, and the society is somewhere else, and we have to sort of understand what kind of mathematics education that distant society needs. But I mean, of course, I mean, we should be asking those questions, and there is not, everyone should be asking every kind of question. But I think I think a more tangible starting point could be if, let's say, people like us, the mathematicians, could openly discuss and write about how our own social locations are impacted by our mathematics, and what does mathematics education mean for us, right? I mean, as from our socioeconomic locations. I mean, that could be, I think, a good start. I mean, at least in terms of for instance, the question I ended my presentation with was a question on trust, right? I mean, why should the rest of society trust us, right? So I think that if we begin with sort of, first of all, thinking of ourselves and our own social locations as real social locations, and talk about how what mathematics and mathematics education has to do with our social location, I think it can be a good starting point to sort of try to build a dialogue with the rest of the society, with whom historically we have been like two alien species. We don't know them, they don't know us. The only transaction we have been like these cold, violent transactions, right? So we can, I think we need to open up that dialogic space, and the only way of doing opening up that dialogic space is to, first of all, for us to talk about ourselves. I think, like, in a critical sense, like, I mean, we should talk about what our mathematics, how it strengthens the state, for instance. We should begin with that, I think.
So thanks, Tathagat. And I think we are kind of done with the round of questions here. And so I would generally like to thank all the speakers, all the panelists who kind of have given like very insightful conversations. I thoroughly enjoyed each and every one of them. And I assume, I think most of the audience also did.